Right. Hi, everybody. Welcome to our presentation for our project language, 200 Benchers Only. It's by Connor, Luke, and Ryan. We hope you enjoy our presentation for our excellent language.
Okay, so is this you using an unintuitive language like Python? Well, we're not. 200 benchers only is here. So only people who can bench 200 plus pounds can effectively use this language. And it is strongly typed and uses type annotations like Java. So for example, it would have like integer, variable name, something, but obviously it's named something different. It's imperative, which just means like you code what you want it to do. And third generation, uh, just a high level general use language. It can be used for anything, like Java and Python. And it can also be considered a scripting language because it's very readable and fast to code in. Once you get the hang of it, and since it's so similar to Java because it's got like curly brace scoping and semicolons, it's translated into Python.
All right, so I'll go ahead and talk about the types here. So first off, getting into the integers, one of the really great features about our programming language is actually that we have a lot more control over the types of integers that we have. So in a language like Java, it can be sometimes really unintuitive that an integer can be something like 1 or 200,000. But in our language, you have so much more control over the types of integers. So for example, if we look at the lightweight variable, of course, when you're at the gym and you're benching, if you're doing anything under 200 pounds, that could definitely be considered lightweight. So anytime you use an integer under 200, it must be annotated with the type of lightweight. Now, a typical normal range is the range of 200 to 1,000 pounds. So that's what we say for our normal weight range is you'll specify with the annotation of weight. Now, Sam Sulek, this guy is the actual GOAT. So if you're ever using an integer over 1,000, to pay our respects to Sam, really, we're going to annotate this with the type of Sam Sulek. And now we, of course, would like to allow for negative integers as well. And we're going to annotate this type with Ryan Bullard. And now Ryan Bullard is actually unbelievably strong, really. So this is really a joke more than anything else. But let's get into the Boolean types now. So if we're going to look at the try bench Boolean type, this can, of course, return true or it can be false. And if we're going to say it's true, we're going to say got it up, because if you got it up, that's obviously a positive. It's true. It's a good thing. Whereas false is more of a negative thing. So we're going to say failed, kind of like you failed your set. Now, if we want to use strings, we could call that cables. For longs, we could call that PRs or PR. And for floats, we're going to call this small plate. And now another really great feature really about our programming language is that the actual only float we can use is the value 2.5. So you can't say like 3.82, for example. And that might sound strange at first, but really it's actually a positive because whenever you're at the gym and you're weightlifting, there never really is a half a pound kind of thing. The only real half a pound that we could see inside of weightlifting is for the 2.5 weights. So that's why we are only going to allow a small plate of 2.5 with no other decimals.
So all of our variable names are named after muscle groups because we want our users to keep in mind their workouts as they code in this language. So you can have anything like pecs, delts, lats, biceps, abs, etc. And you can add numbers on the end, so you're not limited to just a few variables in a function. So you can have pecs 1, pecs 1, 2, 3, etc. And this is usually because when you're training a muscle group, you're like assigning weight to that. You're pushing up weights. You got to be able to lift that. And so to reflect that, we have our assignment as load bar. At the end of every statement, we have pump as a semicolon. So it's like you've loaded up all the weight now. You're going to pump that to prove that you can actually lift that. Your muscle group can lift that. And here's an example of assigning an integer to 2,000. So Sam Sulek for our integers over 1,000. Glutes, that's one of our muscle names you're allowed to use. Load bar for assignment, 2,000 for the value, pump for the end of the line. It's pretty simple. It's very similar to Java syntax.
So now let's get into some integer operations. And you can use some of these with other types as well, like strings, or I mean cables. Um, so first one is creatine, right? So creatine right here, it's addition because creatine adds to your gains, and all of these follow this. It basically just replaces the sign. Subtraction is rest days because rest days are for the weak, and they subtract from your gains. Multiplication is steroids because if you're taking steroids, you can look like this guy, and it's definitely multiplying your gains. Division is vegan because they can't eat meat, so they're dividing their gains. Modulus is muscle mass because you're taking the remainder of your muscle, from your overall mass, hence why it's that. And we also added an extra thing, increment, and this is superset. So it just looks like this, like variable superset, and it just adds one to it because you add one to your set.
So we have all the appropriate Boolean and comparison operations like and, or, not, and then greater than, less than, or equal to. But we gave them names that fit with the bencher theme of our language. So and is crushed because if the weight crushes you and you're a really good lifter, you can work through that. Settle, if you fail on something, you'll settle for what you actually can succeed at. You're weak, so you're settling. Not is spotter because a spotter will be able to prevent you from failing if you do fail, but also if you do succeed, the spotter was useless, and so you're actually technically weak because you should have just known that you would succeed. So we have that as not. Greater than, bigger than, because you're going to compare your muscle groups to someone else. You want to make sure that your muscles are bigger than theirs. Smaller than or equal to, same thing. You're comparing muscles to other people. Right? That guy, he'd be bigger than most other people, so he's always getting it up. And our loops, we're basing this heavily off the Python range syntax, since that's a very intuitive syntax for it. You set what you want your variable to be, what the range is going to be, and then you can have all your statements in the loop between the left and right wait clips, which we'll explain on the next slide. Java, our if statements are also very similar to Java, the syntax, but the structure is similar to SML because we only have if, then, else statements. We don't have if, else, else if. You can only have if. Well, you can have if by itself. And it's very similar syntax to Java. So it's can you lift or if. Then you have parentheses, your condition, some kind of scope indicator, another scope indicator. Our else is you're a failure. So because if you can't lift your condition, you're a failure. And then our next scope. So it's pretty simple. It's just different tokens for each symbol.
All right, now for some of the additional miscellaneous features. So the first thing I want to talk about is the functions inside of our language. Now, typically when you're coding in a language like Java or Python, it tends to be the best practice to just have your function accomplish one task. Having a do-all function is typically not a good idea. And the same idea holds for a workout. So when you're working out, you want to just target one muscle group. So that's why if you are going to use a function in our language, you need to say workout to specify it's a function, followed by the return type, followed by the name of the function. And then additionally, you're going to include the parameters. Now, for our scoping is a little bit similar to Java. So Java uses the left and right curly brackets to indicate the start and end of a scope. And the same idea holds for our language, but we're instead going to use our left wait clip and our right wait clip. Because of course, these wait clips are used to hold stuff on a bar. So a bar in which we are holding the weights on could be thought of as our scope. Now for return, we're going to say gains because for gains, you're trying to give out additional data. As in Python, you'd give out additional data, whereas gains, you're trying to gain on muscle. And now for print, we could say show off right here because we're trying to show off to the console. We're going to show off all of our gains, so to speak. And now I want to spend some time talking about the command line arguments that our program handles to take in. So there's really three options that we can have here. The first of which is if none. So if no arguments are passed on the command line. And in this case, we're going to run our program in debug mode. And kind of what I mean by that is this means that on the command line itself, or in the terminal, sorry, we're going to take in certain lines from our program from the user. And what our program will do, it will actually show you the parsing process of the individual lines. And you could do that for one or multiple lines. And then at the end, when you exit out, it's going to go ahead and show you the converted Python code. Now, the next option we have is if just one command line argument is passed in. And in that case, we're expecting that the first command line argument is going to be the name of the file. And the name of the file is going to contain the code for our 200 benchers only code. And so our program will then go through and it will convert that whole entire file into Python code so that the Python code can then be executed. But we also allow for additional command line arguments. So say you pass the name of the file followed by a bunch of other values. Our program will take all of those additional values and it will turn it into variable assignments in Python. So that way command line arguments can be used as they would in Python. And we also allow for additional nice features, such as if they pass in an integer, it will actually be viewed as an integer. Now, the last thing I'll talk about here is we added in some commenting. So to comment, we could just say to Jim Bro, and then whatever your comment is going to be.
For our added features, I just wanted to encompass everything. Some of these we've already talked about. So first of all, we have an interactive system typing command to show the parsing process. We'll get to all this in the coding demo, but yeah, so you can go line by line and it'll tell you all the breakdown of your statement. We have a scoping system where we can use variables, if they're within the scope for variable names and function names. We have some generic error messages for if and it'll tell you the line number that's wrong. We have custom names for basically everything. We have more integer subtypes, as Luke talked about. It's very useful for the language. We have floats and longs. Technically you're a little bit limited by the 2.5, but we also added incrementing, commenting. Another cool thing we added was type checking. So it actually checks to see if the left side agrees with the right side. And we had a bunch of stuff for that. And then we have function names and calls, which you can call within stuff, and it's very useful for the workouts.
So our process was pretty similar to, I think, a lot of other groups. We started off with the example code we were given, which had a couple different regexes that we actually did end up using a lot of the sample ones that we had. But then we tinkered with that, trying to add our own regexes to find our own limitations, because we had planned out what we wanted the language to look like in a general sense before getting that example code. And then we went in, added a bunch of more regexes for all of our different kinds of statements and the ones that were lacking in the original example code. And then we wrote functions to match them. And we had a main class that could actually test to see that our example code that we had written for our language during our planning process could actually be parsed and matched. And then once we had everything working most of the way, we then added to the parser to actually try and translate each line into Python. And then from there, we added type checking and exceptions to throw up if the line is invalid when translating, so we can make sure all of our code is accurate. And then after that, we wrote more sample programs, longer ones that were more complex, to test that everything was working properly, fix any bugs that came up, and then just did general code polish and cleanup, so it would be easy and understandable to pass on to the next group.
All right, so for some of the challenges we ran into, one big challenge is that we decided to include block scoping. And this was quite difficult because we, of course, had to manage all of our variables and which variable was in which block. But eventually, after the use of some special data structures, we were able to successfully accomplish this. And another issue we ran into is with throwing exceptions. And kind of what I mean by that, the way we handled our code is that we would check if a line is valid, and if it was invalid, we would have it throw an exception in a way kind of indicating that the line was not correct. And so getting everything working properly in that sense, that definitely caused some issues. And the next thing was the indentation of Python lines. So Python is different from a language like Java in the sense that it is very important that it is indented properly. So we had to make sure that everything was indented properly and that the scopes would match up as they should have in Python. So it took some time to get that to work. Another issue is with our regex expressions and getting it to separate out our different expressions. And what I mean by that is, for example, we have a bunch of different types of expressions. You could have a return statement or a function statement or a declaration statement of a variable. So we can have all these different things. And so we had to figure out how to have our code and how to have the regex be able to determine which line we're actually looking at. And the last challenge I'll get into here was type checking. So we ran into some issues with type checking because we decided to add it at the very end, which adding it at the end caused us some issues as we had to change some of our implementation details. But overall, after some time and thought, we were able to work out all of these issues. All right, now for the coding demo itself. So this is a 200 benchers only programming language, which means that you have to be able to bench 200 to use this language. And of course, for someone like me, I could easily bench 200, but it's important to showcase proof. So I'm just going to show this video just to show you that I'm really able to do this quite easily, actually.
Oh, well, okay. As you can see, my group member barely missed it. That's okay though. Uh, here I'll take over here for the code demo. Here's just some proof that I can in fact bench 200. Okay, so a little wobbly there then, but we got there. So let me just get into this code demo here. So for this code demo, for the sake of time, I've prepared a file where it has all the features of our language. So it has three functions basically. One's just a general gym session where it goes over some general like integer operations. It's got a loop here. Just so you can see some of the syntax and it in action. And then here it should well, I have comments on what it should print on each line when we get to translating and testing it. Um, and then the second one is just a simple workout plan. So it's gonna add 100 sit-ups, 100 push-ups, 100 squats, and a 10 kilometer run a day. And if it equals that, then you should be Saitama. So it should return Saitama and print that off here. And the last one is just to check the booleans to make sure you really can bench 200. So it takes in two parameters, compares them with an and if you can get it up with tri bench on your pecs and triceps, then it should be valid and you should be a 200 bencher. But if either of these are false, it should return false. So we have some tests here for that. So the way you would run this, as described in the slides, you go into run configurations, arguments, and we would put in the file we want to test. So let's do sample file.txt. We can add just some general parameters here separated by spaces, and they should make variables in our language. So let's apply this and run it. Now, since we're running it in normal mode, it'll just spit out the Python code for us. So here are the three variables we initialized. Here's everything translated. So def is like a function declaration. It's got all the math, all this stuff. So at the end of this, all the math should add up to 6969, and it should print out good work because glutes is in fact greater than 200. And here's just here's all the string stuff. You can multiply with strings, all that. And by the way, we white space does not matter. It ignores white space when parsing, so you can have as much white space or blank lines as you want. So let's just make sure that this really is valid Python code really quick. Just gonna get an online compiler. So I already have it here, but let me just paste it again, run it. So the first thing it should print is true, and at this point, this variable should be 2,854. So that is in fact greater than this, so it should print true, and it does. This should print good work because glutes is higher than that, and it does. The next thing it should print is Saitama if this string is equal, and that is also valid. And then if both of these are true, it should print true, and if one of these are false, it should print false. So this code does in fact work, and it parsed correctly. All right. So now let's get into some invalid code. Obviously there's a lot of invalid code, but we'll just go. Oh, actually, first let's get into the debug mode. So if you have no parameters, just remove all these, apply, run. If you have no parameters, then it'll go line by line, and you can put in stuff, test it. So I'll just put in a couple lines of these. So you just click enter, and it'll give you the breakdown of the parsing process. So these are in fact types. This is a variable declaration, and it expands until it gets to a variable declaration list within the function, and then finally a function declaration. And this is in fact a function declaration. This is a little bit nicer view. Tells you the name, return value, all this stuff. And let's just put this first line in some of the variables. Again, this one is a variable assignment instead. And then let's just end it with a right way clip. And to get the Python code, you just do leave gem, and this is what this function looks like in Python. So this all parsed correctly. If you give it an invalid line, it would tell you. So for example, let me just put this one in. This one says on line 1, it's invalid. And obviously we cannot have string in our language, so this is invalid. Now, if we want to change that, we would just make this cables. And then run that again, and that should be valid. And we also, if we want to use a variable that we have not used yet, then that will catch that and be invalid because you need to, you got to hit the gym before you can use that muscle group. So you have to define it before you use it. That's just a little bit of the scoping and type checking we have. Now, just a couple more exceptions we have. So if you try to, this is using a variable, so this will do the same thing. This will say you have to hit the gym. This is also the error message it gives. So yeah, we've already seen that one. And this is one where you don't the left way clip and right way clip does not align, so the scoping is incorrect. So if we put in these two lines and then try to leave, or actually we have to do enter, then try to leave the gym, should give an error. Yep. So there's an unmatching left and right way clip, and we could just fix that by adding a right way clip here. Okay.
So there are a few things we would have liked to have added or changed. We want to add more type checking for cases that we missed. Our type checking isn't the most complete. It'll check if there are invalid stuff like we showed in our code demo, but there are some cases that we feel might be inadequate. But for general use, it should be fine. But if someone is trying to break the language, it'll possibly have some holes. We would definitely like to add more custom error messages. So we just don't have error messages for these things. It'll just crash if you try to do these things like assigning 100 to a weight variable. We wanted to put something like that's a lightweight body instead of just crashing. Also maybe else if statements just for ease of use, but it's still possible to do this with
Nested.
nested ifs. And we did enjoy coming up with the gym puns, so we wanted to add more features that would have more gym puns, because that was a very fun part of making this language. So thanks for watching our presentation. We hope you enjoyed the language and are ready to start your journey to becoming a 200 bencher.